So let's talk about the definition of derivative. Now typically when you're asked to write the definition of derivative, you have to write f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And you have to write every term here. You can't omit the limit, you can't omit any part of the secant slope, and you cannot omit f prime of x is equal to on the left hand side. So you have to write the whole expression. Now let's solve a simple problem by this definition. So suppose we want to differentiate f of x equals x squared by this definition. Now using the power rule of differentiation, we can write this as f prime of x equals 2x. So this is our target. I always recommend solving it this way in advance so that you can compare your answer from this calculation with this result. Now f prime of x will equal the limit as h goes to 0 of f of x plus h minus f of x divided by h. Good first step, always write the definition. That way your teacher knows that you know the definition. Then we're ready to take the composition of this argument x plus h with this function x squared. So we have x plus h squared minus x squared divided by h. Now notice at this stage that this limit is 0 over 0 when you plug in h equals 0. It's x squared minus x squared over h, and the limit as h goes to 0. That's 0 over 0. So typically the problem requires that you expand and simplify and cancel h over h in order to eliminate 0 over 0. So this will be x squared plus 2xh plus h squared minus x squared divided by h. And now we're ready to make some cancellation. Notice that this term cancels this term. And so we simplify the limit as h goes to 0 of 2xh plus h squared divided by h. And now we cancel a factor of h. Here, here the square, and here. And we get the limit as h goes to 0 of 2x plus h. Now take the limit and you get 2x. In so taking this limit, we're letting this h go to 0. And that's our answer. F of x is equal to the square root of x. Again, you can take the derivative using the power rule, and this would be 1 over 2 root x. Now, if we want to take the derivative, by definition, our first step will be to write the definition of derivative. The limit as h goes to 0, f of x plus h minus f of x divided by h. Then we plug in the argument x plus h for x. So this is the limit as h goes to 0 of the square root of x plus h minus the square root of x divided by h. Now, if we take h and let it equal 0, we get the square root of x minus the square root of x divided by 0. 0 minus 0 over 0, this is 0 over 0. And so what we need to do is use the classic technique of multiply by the conjugate in order to simplify this. So this is going to be the limit as h goes to 0, the square root of x plus h minus the square root of x divided by h times the square root of x plus h plus the square root of x divided by the square root of x plus h plus the square root of x. Notice this is multiplication by 1. And we talk about the conjugate, where you've seen that before, is a plus and minus bi for the roots of a parabola. This is called a conjugate pair, or a complex conjugate pair. And here we have the minus, and here we have the plus, and that makes for a very nice multiplication that gets rid of the radicals. The limit as h goes to 0, then this term times this term, and this term times this term, and the middle terms cancel out. So you just end up with x plus h minus x divided by h times the square root of x plus h plus the square root of x. And now we're able to make this cancellation of positive x with minus x. This becomes the limit as h goes to 0 of h divided by h times the square root of x plus h plus the square root of x. Now this h cancels this h, and no longer do we have 0 over 0. This cancellation here is literally canceling 0 over 0 out of the problem. And so now we have a limit that no longer is undefined. It's 1 over the square root of x plus h minus the square root of x plus the square root of x. And so this one is equal to 1 over the square root of x plus the square root of x is 1 over 2 root x, which is the same answer as this one. We want to take the derivative of 1 over 3x plus 1 by definition. So here, f prime of x is written 3x plus 1 to the minus 1 power, and then let's hit this with the power rule and chain rule. So this will be minus 3x plus 1 squared times the derivative of 3x plus 1 prime. So here we have chain rule for this term, 3. So this becomes minus 3 divided by 3x plus 1, the quantity squared. Now, if we want to take the derivative using the definition, let's write the definition. F prime of x equals the limit. Oops, as delta, I was going to write delta x goes to 0. That's an equivalent notation, which would be like this. I suppose it's worth mentioning at this point that some textbooks and teachers use this. However, in this video, I've been using the limit as h goes to 0 of f of x plus h minus f of x divided by h, which is an equivalent notation. Just substitute h for delta x here. Now we're ready to substitute this for x and this for x. So one way I like to think of this is if I have f of a square is equal to the square squared, then f of x plus h would be x plus h squared. So this is sort of how the function composition works if you haven't caught on to that feature. Whatever this argument is here, that goes here. This argument, the same. So here, the limit as h goes to 0 of 1 over 3 times x plus h plus 1 minus 1 over 3 x plus 1 divided by h. And now we have to combine these fractions by finding a common denominator. So we multiply this term by 3x plus 1 over 3x plus 1, and this term by this term over itself. So this will look like the limit as h goes to 0, 3x plus 1 divided by 3x plus 1. This is 1 times 1 over 3x plus h plus 1 minus 1 divided by 3x plus 1 times, and then this term over itself. So 3 times x plus h plus 1 divided by 3 times x plus h plus 1, the whole thing divided by h still. Now all we did is we multiply by 1 and by 1. And so now these have the same denominator. This is the limit as h goes to 0 of 3x plus 1 minus this quantity, 3x plus h plus 1. And very important, there are parentheses here like this. So this minus sign has to distribute across the sum, divided by the common denominator, which is 3x plus 1 times 3x plus h plus 1, again with the parentheses, and now we can divide by h or multiply by the reciprocal, which brings this to the same denominator. Now we're going to simplify this numerator, and we should get a lot of cancellation. This is the limit as h goes to 0, 3x plus 1 minus 3x minus 3h minus 1 divided by 3x plus 1 times 3x x plus h plus 1 times h. And now if we look at the cancellation that we have plus 3x minus 3x. And we have plus 1 and minus 1. And so all we're left with is this term here. And h here cancels h here. So in the numerator, only minus 3 is left. All that survives is minus 3. And in the denominator, what survives is this term here. We then would get the limit as h goes to 0 of minus 3 divided by 3x plus 1 times 3x plus h plus 1. And now, when we take this limit, the only h left is this one here. And so this becomes minus 3 divided by 3x plus 1 times 3x plus 1, which is this term here as h goes to 0. And so this is equal to minus 3 over 3x plus 1 squared, which is exactly the derivative we were looking for.